Accessing leaked databases is a complex subject that requires careful consideration of both technical methods and significant legal and ethical implications. As attempting to obtain or use such data without proper authorization violates cybersecurity laws in most jurisdictions worldwide. For legitimate security professionals and researchers who need to investigate data breaches as part of authorized defensive operations, there are several technical approaches to monitor for exposed information while maintaining legal compliance, beginning with specialized breach notification services like Have I Been Pwned, which aggregates data from publicly disclosed breaches and allows individuals to check whether their credentials have been compromised without directly accessing the raw stolen data. More advanced threat intelligence platforms, such as DeHashed Snoopspace and Breach Directory, provide searchable interfaces of credential dumps from historical breaches. Though these services typically hash or otherwise obscure sensitive information to prevent misuse while still enabling security teams to identify compromised accounts within their organizations. On the darker end of the spectrum, leaked databases frequently circulate on underground forums, dark web marketplaces, and peer-to-peer networks, where cybercriminals trade, sell, or freely distribute stolen information. Security analysts with proper legal authority may monitor these sources using Tor-enabled crawlers and dark web intelligence tools like DarkOwl or Recorded Future that aggregate and analyze these illegal listings without directly participating in the transactions. Many large-scale breaches initially appear on paste sites like Pastebin or Ghostbin before spreading to more obscure forums. This leads some security teams to implement automated monitoring of these platforms using APIs and custom scripts that flag mentions of their domains or other identifying information, while carefully avoiding downloading the actual stolen datasets. The ransomware ecosystem has also become a major source of leaked data, with many groups operating leak sites where they publicly post samples of stolen files as extortion leverage. These are sometimes indexed by security researchers tracking ransomware campaigns. From a technical standpoint, leaked databases typically appear in standardized formats that security professionals learn to recognize. Common structures include SQL database dumps, compressed archives, comma-separated values files, and specialized formats like MongoDB BSON exports, often accompanied by README files describing the contents or boasting about the breach's significance. The contents frequently follow predictable patterns containing usernames, email addresses, hashed or plaintext passwords, IP addresses, and sometimes more sensitive personal information like government ID numbers or financial records, depending on the compromised service. Security analysts working with authorized access to such data for defensive purposes typically employ specialized tooling to process and analyze these datasets safely. Virtualized environments with no network connectivity, cryptographic hashing of sensitive fields before analysis, and strict access controls to prevent accidental exposure. Tools like Hashcat or John the Ripper may be used to crack password hashes with proper authorization to assess whether employees are reusing credentials across corporate and personal accounts. And, custom Python scripts using libraries like Pandas help parse and analyze large breach datasets efficiently. The ethical and legal landscape surrounding leaked database access presents numerous pitfalls. Even security professionals conducting research may face liability if they improperly handle stolen data, as laws like the US Computer Fraud and Abuse Act are quite strict. Many jurisdictions consider merely downloading a leaked database even for research purposes as unauthorized access to computer systems, potentially carrying criminal penalties. So, it's really important to be aware of the legal implications. Responsible security teams establish clear protocols before engaging with breached data. This includes documented authorization from legal counsel, minimization of data exposure by working with hashes rather than plaintext when possible, and strict time limits for retention of any downloaded materials. The cybersecurity community has developed best practices like the clean room approach. In this method, analysts work with breach data in isolated environments without internet connectivity. They also ensure to destroy all copies after completing the necessary analysis. For individuals concerned about personal data exposure, safer alternatives exist beyond attempting to access raw breach data. Password managers like 1Password or Bitwarden include breach monitoring features that check saved credentials against databases of known leaks. Additionally, browser extensions like Firefox Monitor provide similar functionality by integrating with Have I Been Pwned's API. Many consumer security suites from companies like Norton or McAfee now incorporate dark web scanning that alerts users if their information appears in new breaches. Corporate security teams often implement similar monitoring at scale through enterprise password managers or dedicated dark web monitoring services that provide alerts about compromised business credentials without requiring direct access to illicit sources. The emergence of decentralized technologies like Apple's Private Relay and various burner email services also helps users proactively minimize exposure by using unique, disposable identifiers for different online services, making any potential future breaches less damaging even if they occur. The underground economy surrounding leaked databases operates with surprising sophistication. Breaches are often seeded with canary records that allow the original leaker to track unauthorized redistribution. Additionally, some cybercriminal groups use watermarking techniques to identify customers who leak their exclusive datasets to competitors. Prices vary dramatically based on the data's freshness, exclusivity, and perceived value. Recent breaches from major platforms may sell for thousands of dollars in cryptocurrency on invitation-only forums, while older compilations circulate freely on torrent sites and Telegram channels. Some hackers specialize in combing multiple older breaches to create enriched profiles containing passwords reused across multiple services. This practice enables particularly effective credential stuffing attacks. The lifecycle of a typical breach database progresses from initial private sale to wider distribution in criminal circles, eventual leakage to public forums, and finally aggregation into security services monitoring systems, a process that may take months or even years depending on the data's sensitivity and the leaker's motivations. From a defensive security perspective, working with leaked data requires careful consideration of operational security. Analysts must assume that any tools or techniques used to access breach repositories may themselves be compromised, with criminal groups monitoring security researchers' activities and potentially planting booby-trapped files containing malware. Common precautions include using dedicated virtual machines for analysis, carefully sanitizing any metadata from downloaded files, and verifying the cryptographic hashes of known breach datasets to avoid poisoned or falsified versions. The cybersecurity community maintains several trusted repositories like the Collection No. 1 archive at academic institutions, where researchers can access sanitized breach data for legitimate study under controlled conditions. Emerging technologies are changing how both attackers and defenders interact with breached data. Blockchain analysis tools now allow tracking cryptocurrency payments associated with database sales on dark web markets, while machine learning systems can identify patterns in credential reuse that help predict which stolen passwords pose the greatest risk to enterprises. Privacy-enhancing technologies like homomorphic encryption may eventually allow security teams to check for credential exposure without ever handling the actual breached data. For now, the safest approach remains leveraging reputable breach notification services rather than attempting direct access to leaked databases. The legal risks far outweigh any potential benefits for most individuals and organizations. The constant evolution of both breach techniques and defensive countermeasures ensures this remains a dynamic area of cybersecurity practice, requiring professionals to stay informed about legal developments and ethical best practices alongside the technical aspects of data breach analysis.